Hello and welcome to this screencast about functional programming. During this screencast, I will explain you some concepts of functional programming. To do that, I will solve the problem first the imperative way and then refactor it to the functional way. The problem is pretty simple. My goal is to find a movie by title in a collection. So I have a function, find by title, which takes one parameter, which is the query, what I'm searching for. The title of all the output should match this query, and then I have the collection of my movies. Okay, so as you can see, the first test, I'm searching for Interstellar in a collection that doesn't contain Interstellar, so the output should be empty. And of course, my test doesn't pass. Okay, now let's make it pass. Find my title, which takes a query and a collection. And to make that test pass, I just have to return the empty list. Okay, my code is pretty simple. My test too, so let's write the next test. So the next test is, let's return a movie, a matching movie. So if I'm searching for something like the matrix, then my output should be equal to a list containing the matrix. Well, it doesn't work. Okay, let's fix that. If my query is equal to the matrix, then I should return a collection containing the first element of my collection, which is the matrix. It passed my test. Now I can start a bit refactoring. So let's do that. I create a variable named result, and I will push in the result the first element. Still pass. Let's add some braces to make it clearer. Okay. Okay, now my code is quite simple. I can write the next one. Let's write the next test. The next test will be to return all the matching movies. So let's say I'm searching for something containing O. I should find Untitled Chapter and Forrest Gump. So that's my new output. And it doesn't work. Let's make it pass. It's pretty simple. I just have to go through all the movie. So I can get a movie from the collection. Then, well, if the movie title contains the query, I just have to push the movie. And done. I solved my problem. I solved it the imperative way, and we all know about that. We all know how it works, and just have to explain to the computer how to do stuff. That the way we all use to code. And it's imperative because I only have one entry point, and I explain the computer how to work. I can do something a bit special here. So let's define a function matches. Okay, and now it's procedural code, because now I have more than one entry point, more than one function to my program. That's the whole difference between imperative and procedural code. The cool thing about procedures is I can use it a lot. Let's define a new method that returns the title of a movie. Let's define another one that check if something is included inside another string, but I don't like the name include, so I can rename it. Isn't fix off because I don't know, I like that name. So that's cool things I can do, and I can do it thanks to procedures. And well, let's say someone told me one day I should not have 2 levels of indentation in my code. I can move this, name it add if matches. It allows me a lot of refactoring and change my code the way I want to. Very powerful. That's cool. So that the refactoring I did, I'm fine with that. And now let's refactor our test. I see in my test that I'm using always the same collection of movies. So let's extract it to a variable name movies. Let's move it. So now I can use it to all my tests. And it doesn't work. That's pretty strange. I just move some code that is duplicated. So I remove the duplication, but I broke my code. That's pretty strange. Well, I don't like it. Let's try to understand why. The reason is, while coding the find by title, I used shift. And what shift does is return the first element of a collection and removes it from the collection. That's what we call side effects, because I have a input, a parameter as an input, and I change the value while evaluating my function. And side effects make the code way harder to resonate about. So that's clearly something we would like to avoid. Let's try to avoid that. It's pretty simple here. Just say for the movie of my collection. And now what it does is just iterate through the collection and then change the value of it, so my test pass, and that's great. But it means side effects are a bit problematic. So let's try to find a way to see the obvious side effects. To do that, I will add the signatures of my functions. So, for example, title is a function that takes a movie as a parameter and returns a string. Simple. A bit more complicated is in fixoff. is a function that takes two strings and returns a boolean. Matches is a function that takes a string and a movie and returns a boolean. Okay. Add if matches is a function that takes a string, a movie, and an array of movie and returns nothing. Oh, okay. That means add if matches do some side effects. Can be another way. Why? Well, the reason is add if matches is useful to my program. It's useful because if I remove it, my test won't pass. Let's see it. I removed it, my test don't pass. Okay, so that's the proof that add if matches is useful. But add if matches doesn't return anything. So the only way for that function to be useful is to do some stuff to the parameters. And indeed, well, on this line, it's adding to the parameter result the movie using push. So it's changing the parameter result value. So that's something we would like to avoid. Let's check if you have other side effects. So a find by title takes a string and an array of movie and returns an array of movie. This method seems like it's side effect free, looking at the signature. As we saw before, it wasn't. So the signature is not enough to be sure it's side effect free, but it's enough to know there is some side effects. Just because I return nothing means I have some side effects. Okay. Let's try to fix the side effect of the add if matches method. To do that, I will need to introduce some concepts of functional programming. The first one, I'm pretty sure you already know it. So I create a parameter, a variable predicate, and it's equal to the function matches. So I save a function to a variable. Doing that is very special because it means that the function matches is handled the same way that the empty array, the line before, is handled. So it means that functions are treated the same way as values are. That's another way to say it is functions are first-class citizens. It's all that functions are first-class citizens just mean I can have a function inside a variable. Okay. Now, since I can do that, I can obviously give the predicate as a parameter to my function add if matches. So my test will still pass, and of course, well, I can use it as a replacement for matches. So I just have to use predicate instead of matches, and it does the same thing because predicate equals matches. Now, doing that is another concept of functional programming. because I'm giving to addIfMatches a function, which is predicate, as a parameter. Doing that means addIfMatches is a higher order function. It's just a function taking another function as a parameter or returning a function. It's also higher order functions. Let's show that changing the signature, because now it takes a function like matches as a parameter here. And well, my name is not well chosen anymore. Name is add if my predicate is true. And well, that was the first concept of functional programming. Functions are first-class citizen, which leads us to higher order functions. Let's do something else, because I didn't solve my side effect problem. I can define a new function, let's name it add, which takes a movie and add it to the result. And I'm pretty sure that the kind of things you already seen, but that's something very special again. Because, well, first of all, it's a function as first-class citizen because I save it in the variable. And secondly, I have the usage of the variable result here. And that's pretty strange because result is not a parameter of my function here, just movie is. So I could write almost the same thing by saying, well, it will take movie on movies, and movies will be equal to results by default, and then use movies here. As I said, it's almost the same thing, but it's not actually not. Why? Well, because when I call the function add here, let's say I do add on something else. When I call it, I can't change the value of movie as actually not changing, but set it. I'm saying that movie is equal to this when I call the function, and I can do it with movies too. If I don't, then movies will be equal to results, but if I do, it will be equal to, well, the value I give. So it means that these parameters, movie and movies, are opened. It means when I call the method, I can set the value. That's what we call an opened parameter. But what I did is use result directly. Another way to see it is when I have a hidden parameter named result, which by default is equal to result, but I can't set the value when I call the method. That way I'm sure that the parameter result will always be equal to result. If I can't set the value of a parameter, we say that this parameter is closed. I can't set the value, it's closed to any setting value. So a function that has at least one parameter that is closed is said to be a closure. So what I just said, just did here, is actually a closure. A closure is a function. Since we have first-class citizen for functions, well, closures are too. It's also mean then I can give that function as a parameter to my addIf method. What it does, now is instead of calling result.push, I just call my method add. It works. Okay, let's change the name again, because now it's not add if, but call if. And by the way, I don't need the result anymore, so let's remove it. And let's change the signature, because now I have a function that takes a movie and returns nothing as the parameter. Ooh, it means that here I have some side effects. Okay, but now I'm in position to change the function callif and make it side effect free. And that's pretty simple. Instead of, well, calling the function add with movie, I will just return it. Doing that means I will not do the side effects. I will let the caller do the side effects. And that's very important for functional programming, because what we try to do on functional programming is to push all the side effects to the limits of our system. That way, most of the code is easy to resonate, and when we do side effects, it's always at the limit of our system. So the hard stuff is in one place and one place only. Side effects are not avoidable. We need side effects, because side effects is what makes a program or system useful. If you don't do any side effects, you stay in memory, so it means, well, you're useless. You don't print anything to the screen or to a printer. You don't write it to a disk or on the network or whatever. So basically, the program is useless. So we need side effects, but let's try to push it to the limit of system. So if I can do it for callif, it's a good thing, because I pushed it one step further. Okay, so let's not call add, but return it. Since I did this, I will need an else statement to return another function that actually do nothing. Takes a movie as a parameter, but do nothing with it. So I'll solve my side effects here, but it's not working anymore, because callif now returns me a function. And now I need to call this function with, well, the movie. And now it passed my tests. Okay, so I solved this side effect here. Great. But the bad news is, my code here is more complicated. Bad news here is the word add is duplicated, and same goes here. Actually, the word movie is duplicated. Okay, now instead of using this variable, which is pretty useless, I could inline it. So when you see this parenthesis, close parenthesis, open parenthesis, just mean I finished calling a method that returns me a function, and now I call the next one in a row. Okay, so I had one problem and now I have 4. Let's try to solve these problems. Let's start with the simple one, the fact that add is duplicated. It's pretty easy. If I duplicated the name of the function, I just have to remove one and I solved my problem. But doing that is something very special. It's very special because now I have a function that has no name and is saved in the variable name add. I have a function that has no name. So if I need to talk about that function, well, I will need a name. And a way fun to talk about that kind of function is to name it lambda. That's a lambda function. A lambda function is just a function, the way you know it, that can be a closure, because this one is, but it's just a function that has no name. Nothing scary about lambdas. And it's very simple, and it's the basis of lambda calculus. Lambda calculus is just about using lambda functions everywhere, and that's all, basically. Okay, now, since I can remove the name, I can do it here because the name is not very useful. The function is doing nothing, I can see that, thanks. Okay, now, let's try to remove the side effect here. To do that, I can say, well, I have another parameter, movies, and instead of calling push on it, I can say, well, I call movie with concat, and I concat the movie, and that will be my result. So I return it. That way I don't have any side effects. Well, my code is not working because the signature has changed. Now it's taking 2 parameters, a movie and an array of movie. And returns an array of movie. So that's the new signature, and that's also what I'm giving as an output. So here I need to take 2 parameters, movie and movies, and return movies doing nothing to it. And here, well, now it's waiting for 2 parameters, a movie and movies, which are results so far, and result is equal to the output of the call of the add method. So now it passed my tests. The cool thing is, well, I remove my side effects. I don't have any side effects anywhere anymore. That's great. Okay, let's try to solve the next problem. Next problem is the word movie is duplicated. Oh, by the way, the bad news is my code is way more complicated now, but okay. So let's try to remove the movie usage. To do that, I will heavily use what we've seen so far. So let's do it. I have a function which is add and takes 2 parameters, movie and movies. And I will change it to a function taking 1 parameter, which is movie, and return a function that takes the second parameter, movie, and do the concatenation. That's exactly the same thing. Okay, I'm just using higher order functions because I'm returning a function, closures, because I'm using the movie here. So this function is actually closure, and functions are first-class citizen because I set this in a variable. Okay. Now, well, it means the signature changed again, because now I take a movie and returns a function that takes an array of movie and returns an array of movie. So our output must be aligned. So now I have to do the same thing, which is, well, a function that takes a movie and return the function that takes the other movies and give the result. So my types are aligned now. And the only thing I have to do is change the comma space to, well, call the first function and call the second function. So 2 parentheses. And it works. That's the proof it does exactly the same thing. Okay, but this is very special. So I use heavily functions of first-class citizen and closures on higher order functions to do that. But what I just did is what we call currying. Currying is changing one function that takes n parameters to n functions that takes 1 parameter. It's named after Haskell query, which defined that move. Okay. Now, why is it cool? Well, it's cool because now I have add, which is a function that returns another function and takes the first parameter. So I can give to add the first parameter, which is movie, and doesn't have to give the second parameter. The consequence of that is that now the output will be a function that is waiting for an array of movies and returns an array of movies. So I have to align my types again. It's pretty easy to do here. Now I have a function that takes movie and returns a movie. Easy. And, well, the great news is I don't need movie here anymore because I gave it in call if. Okay, so I don't have the word movie duplicated anymore, and my code is a bit less complicated. What we just did, thanks to currying, is calling the method function add with just 1 parameter instead of 2. That's what we call partial application. I apply the function with not all the parameters it needs, just 1 instead of 2. That's partial application, and I could do it thanks to currying. So it seems pretty cool because it was pretty simple and it allowed me to simplify my code and remove some duplication. Awesome. Let's try to do it more then. To be able to do it more and faster, I will show you another way to write lambdas in JavaScript. Instead of writing the word function, I can use an arrow after the parameter. And since I have only 1 parameter, I can remove the parentheses. And since my code is just 1 line, which is return something, I can remove the curly braces on the return statement. The return keyword, actually, not the whole statement. it works the same way. And obviously I can do it again with the word function, use an arrow instead, remove the parentheses, and I could remove the return keyword on the curly braces, but I won't do it. I won't do it because now I can read my code the same way I'm used to do. Let's do it. Here I have a function that is named find by title and takes two parameters, which are query and collection. Now let's do it here. I have a function. If you squeeze your eyes hard enough, you will read function instead of let. So I have a function that is named add and takes two parameters. The first one is movie, the second one is movies, and it does this stuff. So that's the reason I'm going to keep the return keyword here. Let's do it again. I can remove the word function, remove the parentheses, and I keep the return keyword. Now, let's do it for all functions we defined. It's very fast to do, but I want to use higher order function and curify function at the same time. So it's pretty easy. I can do it that way. Let title equal to this. And now I can remove the word title as we see. I can remove the word function, use an arrow, remove the parentheses. And I just did it. It will work the same way. Okay. Let's do it faster. Instead of writing function, I can write let. I use equal, remove the parentheses, use arrows instead of commas, and I just purified my code. But it doesn't work because I didn't change the way I code the function. It's pretty easy. I just have to change the comma and the space with two parentheses, and I'm done. Okay, let's do it again for matches. Let matches equal a query and a movie and returns is infix of blah blah. The function matches is used in as the predicate for call if. So the calling of matches happens here, so I just have to change the way I call it and it will work again. Okay, let's do it again. With call if will be harder. Call if is equal to a function that takes a predicate, a query, a movie, and function add, and return this. And of course, I have to change the way I call it, which is here. Replace all commas and space with parentheses, and I'm done. And it's not more complicated, it's not simpler, it's just the same way written differently. Let's do it one more time. Let find by title be a function that is using a query and a collection and does this stuff. Let's change the way I call it. So use parentheses instead. And it passed the test. Great. Okay, but now thanks to that, I can do partial applications to every function I defined. Let's change the signature before using partial application. Now I have isInfix of, which is a function taking a string and returns a function that takes a string and returns a boolean. but it's so common that actually I can remove the parentheses and read it the same way. It is in fixoff is taking a string and a string as parameter and returns a boolean, and I also can read it. It in fixoff is taking a string and returns a function that takes a string and returns a boolean. Both ways are correct. So let's do it for everything. Here it's taking a string on the movie and returns a boolean. Codif, well, is taking a function that takes a string on the movie and returns a boolean as a first parameter. I need the parentheses to explain that it's just one parameter, and takes a string on the movie and returns takes a parameter that is a function that takes a movie, an array of movie, and returns a movie, and returns a function that takes an array of movie and returns an array of movie. Okay. Now, same thing goes for find by title, takes a string, a movie, and return an array of movie. Now, let's call matches with the first parameter, which is a query. Now, predicate is just waiting for the movie, not the query anymore. So it's a function now that takes a movie and returns a boolean. So let's use it correctly. And it passed my tests. So now I don't need the query anymore. So I can change my code to remove the query. And the good news is my code is a bit simpler and still pass my tests. Great. So far I could simplify my code a lot. But let's make it even simpler again. Because here I have a method I can extract, and let's name it filter. So filter is taking a predicate and returns a predicate on a collection and returns the new collection. Let's curify it. So let filter be a function that takes a predicate on the collection and this. Let's fix the way I code it, and it still passed my tests. Okay, now filter is a very common function, so I can use actually the one given by JavaScript. It's already in the JavaScript language, so I can use it and say I filter my collection with my predicate. Thanks to that, I can remove this code, which is way simpler. I can even remove the core if method because the filter function is doing the stuff for me. Okay, now let's move filter upward because, well, every function I have here of very simple function that already exist in the language, like title. Well, it's just a way of saying I get the field title of my movie. It's already in the language. Is in fixoff, it's just renaming includes. Includes already exists. Filter is just the curification of the filter function. So everything is already in the language here. So it means the whole business of my problem is solved with these lines of code. Okay, so it's pretty neat and compact way of writing code. Let's continue. I will show you more things about functional programming, but we've seen everything we need so far to do everything I will continue to do, which is functions are first-class citizens and closures, and from that we found everything else, currying, partial applications, higher order functions, etc. Let's continue. I will extract to a variable partial. I name it partial because it's just calling filter partially applied with matches on query. But I can see something very interesting here. The return is just calling partial with the collection, and collection is actually the last parameter I have of my find by title method. Let's make the return statement reappear with the braces. Okay, that's the same thing. It's still curried, still a Lambda function. I just add the curly braces on the return statement. Because thanks to that, I can show you that the partial value is just calling filter matches on query, but is not using the collection. It means I could move upward my line like this, and it still works. My tests are still passing. And now it's obvious that, well, this lambda that takes a collection and return a result which is calling partial with the collection is actually doing exactly the same thing as just partial. So I don't need this lambda. I can say it's just partial. That's the same thing. And still pass my test. Now I can inline the partial. So what I'm saying now is that finding in a collection by title given a query is just filtering what matches the query. Neat. Okay. Let's continue. I will do the same thing here. Extract a variable named partial to make a pattern appear. The pattern is I have a function partial that is called with the output of another function which is title, which is called with a parameter named movie here. And I can find the same thing here, which is I have a function filter which is called with the output of a function matches, which is called with a parameter query. Another way to say that is I have a function f, which in that case is partial, which is named with the result of another function j, which is called with a parameter x. So f here is partial, j is title, and x in the movie. I have here a function f filter, function g batches, and is called with the query x. So that's the pattern. And in functional programming, when we find a pattern, well, we write a function. So let's name it compose. And compose, let's write it the curried way directly. So compose is a function that takes a function f and another function g and a parameter x, and it returns the call of f on j with x. Okay, great. Now I can use it. Let's use it. So I compose partial with title and movie. So I use my pattern here still pass my test. And here I compose, filter with matches and query, and I use my pattern. Okay, let's now inline partial. Great. So I use what we call function composition. That's it. This function here is function composition. We've seen it all. And it's very common in functional programming, so common that, well, it's embedded in the language usually. So again, all my business stuff is inside these two functions. Everything else is basics in the language. But have a look at it. Now I have the last parameter to my return statement, which is the last parameter of my function. Hey, let's extract a partial method. And let's make reappear the return statement with the curly braces. Now I can see that composing things of query title is not using movie, so I can move it one line up. Still pass my test, so now this lambda is just the same thing as partial, and I can inline it. Great. Let's do it here too, because I have the same thing. The last parameter is of my return statement is the same as the last parameter of my function. So I can extract a partial method. I'm not using it using query, so I can move it one line up. So now this lambda is the same thing as partial, and I can inline it. And it still pass my test. Let's do it again, but faster. Okay, I will not extract the partial method here. What I can say is, well, the last parameter is of my return statement is the same as the last parameter of my function. So, well, I can remove it. So I can remove the last parameter, and I get the same thing, still pass my test. And now we have a very functional way of solving our problem. Right now I will remove the return statement of matches to make you realize that all my business code is in these two lines of code. And that's all. Everything else is basics for the language. Okay. Now, let me prove you how functional this is. So I will talk about a language which is named Haskell. So this is Haskell. Haskell is a purely functional language. It means I can't do anything else except functional programming with it. And it's also a strongly typed language. It means I can't create objects out of nowhere like I did in JavaScript. I have to create a type for it. And well, the type is here. So that type movie, I can create it with the constructor movie, which takes a title as a string and a year as an integer, and will create me a movie. That way I can create movies. By the way, I can also print the movies. I can show it to my user, and I can test the equality of two movies. Thanks to that, I can write, well, exactly the same test I have in my JavaScript code. So I can run it. and well, my test doesn't pass because the function doesn't exist, right? Same problem as in JavaScript. Now, let's copy paste my JavaScript to Haskell. Haskell doesn't use the same characters for commands, so let's change it. Okay, the only thing you can declare in Haskell is variable, so the let function, the let keyword is not useful. I can remove it. And the lambdas are not using double arrows but simple arrows, and well, to declare that it's a lambda, I use the character that is the closest to the lambda character, which is on my keyboard, which is this one. So that's the lambda, taking one parameter query and return compose blah blah. And finally, compose is a very common function, so I don't use the word compose. I use dot. So it's exactly the same thing. Now I can run the code and pass my tests, so it works. Yay! So that's the proof that the way we wrote it is very functional, because it's run in Haskell. Now, the reason it's named dot is because when I use a function that is only special characters in Haskell, I can infix it like this instead of using it here. So I can remove it from here, sorry, and use it here, and it still pass my tests. I don't need parentheses either, because I use spaces to call method with parameters and to separate it. So I can remove it here. I also don't need the semicolon in the end of my lines, and this should pass my test. Yay! Okay, writing lambdas is not very readable, so they create some syntactic sugar, which consists of putting the name of the parameter when I declare my method and remove the lambda. It's exactly the same thing actually. At compile time, Haskell, we've changed it the way we wrote it before. Still pass my test. And now, as I said, Haskell is a strongly typed language, so I can declare my types. And the way I do it, well, is uncommenting the line before. I'm saying that matches is a function taking a string and a movie and returns a boolean. And it still passed my test. And that's it. We refactor our JavaScript code, which was imperative, to purely functional code, which is written in Haskell. Thanks for watching. And if you want to learn functional programming, I highly recommend you to use a purely functional language like Haskell. The reason is Haskell will force you to use functional way of coding, whereas language that allows you to use different paradigms like Scala, for example, which allows you to use object-oriented programming and functional programming, which is a great language, by the way, but it doesn't force you to use functional programming. So if you want to learn it, well, if you start with Scala, you will learn a bit about functional programming, but as soon as you will have an impediment, you will fall back to what you're used to, which is object-oriented programming. And that way you won't learn about functional programming. So you want something that tells you, hey, you're not using functional programming, like Haskell. And once you know how to code in Haskell, go to learn Scala and use it in production. That's fine, but you go there once you know how to use functional programming. That's it for that screencast. Thanks a lot, and see you soon. Bye.